The Big Bang Theory has a big problem. This video identifies the problem and gives you the solution. To do that, we dive into the heart of one of the most captivating theories in astrophysics, the Big Bang Theory. But hold on, is it a single theory or a series of evolving ideas? Let's find out. Is the Big Bang Theory a single, unchanging concept, or has it evolved over time? Let's unravel the layers and see how our understanding has developed. At its core, the Big Bang Theory is often considered a single, overarching explanation for the origin and evolution of the universe. But as we'll see, this theory has undergone refinement and adjustment as our observational tools and understanding have changed. In reality, the Big Bang Theory is a series of theories that have evolved over time. One of the key elements in this evolution is our understanding of redshift measurements. Redshift measurements have played a pivotal role in shaping our understanding of the cosmos. As we observe distant galaxies, we notice a fascinating correlation between their redshifts and distances. When looking at distant galaxies, the data shows a consistent trend. The more distant the galaxies, the more redshift they exhibit. This relationship between distance and redshift laid the groundwork for crucial developments in the Big Bang Theory. Enter Edwin Hubble and his revolutionary 1929 data observations. Very distant galaxies not only exhibit redshift but show a specific trend. The redshift is directly proportional to the distance. This data relationship is called Hubble's law. The proportional increase in redshift can also be referred to as the Hubble constant. The Hubble constant represents the constant rate at which redshift increases with each additional 3.3 light-years distance. So far, we have only discussed what was measured, that being galaxy distances and redshifts. How do we go from these measurements to the Big Bang Theory? This transition required a critical assumption that ties it all together. We assume that all redshift measurements of galaxies equal receding velocities. We assume the redshift measurements equal the speeds that galaxies move away from us. This assumption is the cornerstone of our interpretation of the universe's redshift measurements. The assumption makes us believe the data says distant galaxies are moving away. This cornerstone assumption makes us believe the universe of galaxies is expanding in size. We cannot actually observe or measure galaxy movements toward or away from us. They are too far away to perceive any movement. They appear motionless. However, when using this assumption, we infer that distant galaxies are moving away from us. Moreover, the farther the galaxies, the faster they are receding. Hubble's law shows us the believed velocities continually increase. If we are assuming the very distant galaxies are moving away, then this movement can be worked backward in our minds. If we work backward, tracing the galaxies' away movements, we arrive at a central point. This deduction leads us to surmise that the expansion of the universe started from a central dense point. The Big Bang event is the result of the above theories. It does not stand by itself. It requires the belief that distant galaxies are moving away, based on believing the cornerstone assumption that all redshift equals a galaxy's away movement. So the redshift and distance measurements are factual. Redshifts are assumed to equal receding velocities. We mentally reverse this believed outward movement back to a central beginning point. Then we visualize expansion going forward as the Big Bang event. So data plus an assumption plus inference plus another inference equals the Big Bang Theory. The cornerstone assumption that redshift equals velocity laid the foundation for the subsequent theories that followed. The universe started 13.8 billion years ago in a hot, dense state that began to expand, cool, and evolve into the universe we see today. There was a slight problem. Distant galaxy redshift measurements increased to tremendous amounts. The corresponding velocities were faster than the speed of light. These increasing redshift measurements forced scientists to refine the cornerstone assumption. Cosmologists realized that the Doppler effect could not be causing these believed receding velocities. They had to find another reason to explain the ever-increasing redshift measurements and the corresponding receding velocities. They found their answer with another theory. They associated the believed galaxy movements with the space located between us and the very distant galaxies. They explained the believed galaxy movements with the space expansion theory, proposing a dynamic universe where the fabric of space itself expands in size. With this evolution of thought, they continued to believe the galaxy redshift measurements equaled their movements away from us. But now they explained the movement by believing the empty space, the nothing between us and distant galaxies, grew in size. The nothing became a bigger nothing, moving the distant galaxies farther away. As we conclude our journey into the intricacies of the Big Bang Theory, we find it to be a dynamic and evolving concept tied together by the assumption that galaxy redshift measurements equal receding velocities. In summary, the very distant galaxies have redshift measurements that increase in proportion to the distance. We have assumed that the redshift measurements represent galaxies moving away from us. Space expansion was a theory used to explain this believed movement. If these increasing redshifts do not equal galaxy movements, then the Big Bang Theory has a big problem. If the galaxies are not moving away, there is no movement to work backward to arrive at a central point that later expands as the Big Bang. The Big Bang's big problem can be presented as a question. What if the increasing redshifts were caused by another redshift type which did not include distant galaxies moving? Then the universe would not be expanding and the Big Bang never happened. The newly discovered redshift type is called gravity lens redshift. This redshift has no association to galaxy movements. It ends the Big Bang Theory. It revolutionizes cosmology, astronomy, and astrophysics. This discovery premieres in the new book, Cosmology's Best-Kept Secrets. Gravity lens redshift is the discovery that changes the universe. For a limited time, you can read the book for free. See the link in the description. Subscribe so you won't miss another groundbreaking video. Download the book. Click on the button for the next video. See you there.